I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 19th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. If you enjoyed this video, give us a thumbs up. We'd appreciate it. If you have any questions or comments, just write them in the comments section below. Things get pretty deep in this video, a lot of technical terms. If you don't understand something, just pipe up, give us a note, and we'll reply back as soon as we can. And of course, if you want to subscribe, please do. You can always do it. Just ring the bell there. If not, then go to the of every page on stormsurf.com. That's our website, and there will be a link there to the video as soon as we get it posted. All right, let's get into it. Look at insignificant wave heights for the North Pacific Ocean. We have a gale, yes, a gale in the northwestern Gulf of Alaska, producing 22-foot seas aimed east, and that is just the beginning. There's actually swell hitting Northern California at this moment. Not particularly big, but swell, 7 feet at 12 seconds or something. From a previous gale, remnants of it positioned here off the Pacific Northwest coast. So clearly, fall has started. Hooray! As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, that is a dip in the jet pushing to the south, sort of like right there. What that helps do is create a counterclockwise flow aloft and at the ocean surface. That's the hallmark of low pressure. And low pressure, of course, if it's deep enough, creates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So we have a little trough here, right here in the northwestern Gulf of Alaska. And we already know there's some sort of a fetch and seas being generated there. There is another little trough trying to organize, being supported by stronger winds. Oh, those are about 150, 160 knots. Getting ready to push off the Kuril Islands. This trough here, much weaker with only 110 knot winds. And then a previous trough already pushing into the far Pacific Northwest. That actually, I wouldn't say created a cold front, but it created enough of a trough into Northern California to create some heavy fog and mist and something that almost looked like rain early this morning about 4 a.m., but that is long gone now. All right, let's put this into motion, see what the forecast has in store for us. All right, the first trough continues pushing east into Monday. Ridge, the opposite of a trough. When you get the jet pushing to the north, that creates a clockwise flow aloft, and that is high pressure. So Monday, we expect to see high pressure in control. And then the building trough over in the West Pacific. As we get into Tuesday, this West Pacific trough looking much better, pretty strong, good 160 knot winds or so feeding into it. That should certainly help produce something. And the previous trough fading in the western or in the eastern Gulf. Wednesday, the main focus begins is over the North Dateline region. Again, the trough that was in the west, continuing off to the east. Ridge builds on Thursday into California. Now, it's possible, see this little bit of a trough here, we could get another front, and maybe, I don't want to say precipitation, but a lowering of the moisture level, perhaps, as we get into Wednesday. And then that quickly passes out. Another high pressure, so you get it. Troughs create low pressure, creates cold fronts. Behind them, you typically get a ridge that creates clearing high pressure, and you get this cycle. So trough, high pressure, trough, high pressure. And then let's see what happens as we get into Friday. Friday, the trough pretty much fading out. Things settling down. Where's the jet? It's typically about this time of year, right about 45, and it's maybe a degree or two north there, but not too bad, and with decent winds in it. And then look at this, as we get into Sunday, almost a week out, another trough is forecast moving into the northern Gulf, as pretty much would be expected for this time of year. Northern Gulf, further north you are, the better the odds for gale development. And in late September, early October, that's typically where things happen. But You also see a little bit of something trying to go on here in the far west Pacific. So we'll talk more about that in a minute. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, weak high pressure, 1024 millibar high, creating a gentle northwesterly flow along the North California coast, maybe building to 15 knots off of Central California. But the real focus here is a gale. Well, it was a gale. To have a gale, it has to have 35 knot winds. This is roughly 30 knots, but it was a gale 6 hours ago, 12 hours ago, slowly fading. And you can see as it moves into the northern Gulf, it fades out. We get into Monday, winds build along the coast. Again, that high pressure cycle. New gale though, as we get into, let's see, yes, about Monday night, building over the North Dateline region, up to 45 knot winds. Is that about it? Yep, 40 to 45 knot winds, solid gale, pushing east into the northern Gulf as we get into Thursday. And then fading out. Another one behind that with 45, almost a tiny area, 50 knot winds Friday night, if you believe that. And then 45 knot winds as we get into Sunday. Notice this large tropical system here. Do not really believe that. It's almost a week out. The GFS is notorious for, the GFS model, which this is, notorious for spinning up tropical systems that never materialize. So we're not going to believe it, though. It kind of looks like it wants to build and recurve. If that were to happen, that'd be great, but we're not going to jinx it. We're not even going to think that it exists. In the meantime, Sunday night, a week from now, gale, winds, barely 35 knots in the Gulf of Alaska. Series of swells, likely impacting at least California north of Point Conception, and maybe some energy for Hawaii as well. All right, let's go take a look at the wave models. So here we are. We're going back in time till Thursday. Was that maybe 3 days ago? A little gale built in the Gulf of Alaska. What's that? 18-foot seas. That's not even really a gale. They kind of faded out, pushing into the Gulf with 14, 15-foot seas. The reason we mention it, because there is swell from it impacting Northern California right now. Here's the Point Reyes buoy, 029 high-res CDIP buoy. Updates every half hour, pretty sensitive. You can see swell energy. One peak here at 4.3 feet, another at 4.8 feet, 11 seconds. This one's at about 13 seconds. So you calculate that all together. Real supposed swell wave heights pushing 10 feet. That's as of like right now. I don't know if that's really the case. We'll scroll down here. Per the buoy, swell 8 feet at 12.2 seconds from 304 degrees. Calculated surf height 9.8 feet. Now that's still 2 hours off from hitting even the San Francisco area, and this is as of, was that about 6 p.m.? So about the time sunset hits, maybe the first set will be pushing into Ocean Beach. Is it really going to be 10 foot? No, probably not, but because it is shadowed, right? And there's all sorts of issues around that, but something sizable. Certainly not flat, some real semi-legitimate, officially it'd be wind swell with a 12-second period, 13-second period is where we sort of have the cutoff for the beginning of ground swell, but certainly something to consider. And then as we got into Friday night, well, that system continued in the Gulf while a new system developed over the North Dateline region with 24, 25 foot seas. It was actually up to 29 foot, but we think a lot of that energy was more aimed northeast than due east, just given the way the fetch set up. But still, 24 highest seas over this whole domain, 24.6 feet at 46 north right there. You can actually, there's a little X right there. Or the plus sign is where the maximum seas are, and the X here, if you can find it right there, is where the maximum winds are, and that's the wind speed there. Was it 36 knots? All right, so anyway, pushing through, that was into Sunday morning, and here we are right now, 22-foot seas, still aimed at the Pacific Northwest down into Central California. Now looking forward, we're moving into Monday. This gale pretty much fades out. It's still producing, should produce wind swell all through Monday, but the bulk of the longer period, by that I mean maybe 13 or 14 second period energy, will be done. But a new gale Forecast developing over the North Dateline region, seas to 31 feet. Continuing as we get into Tuesday night, then fading to 29 feet. Now, this is definitely in the Hawaii swell window. You know, it's northwest of Hawaii. So certainly some, maybe a season opener for Hawaii. Nothing huge in size, but just something. That guy moves its way into the northern Gulf on Thursday and Friday, fades out. Then another system behind that, supposedly with 35-foot seas, building to 36 feet. Now, again, this is almost a week out, so that's not believable. And then there's that tropical thing that we believe even less, but still, we'll keep an eye. This all suggests a progressive pattern in the Gulf of Alaska, with gale after gale after gale, each getting a little stronger, each getting a little bit more energy, clearly delineating the change in seasons. And even here we are 180 hours out, and 20 to 22, 23-foot seas almost filling the northern Gulf of Alaska. That's a good sign. So clearly, we are in a transitional period. And then the southern hemi. So we had 5 or 6 days of swell all last week. Nothing huge, but not bad. I mean, overhead surf for days on end. And then as soon as that happened, and as soon as the northern hemi woke up, the southern hemi just went to sleep. I mean, yes, there is this gale that occurred here with like 20 or 22 or 3-foot seas. That's maybe 14-second period pushing up into exposed breaks in Southern California. Now for Peru, Chile, yes, swell for them. For mainland U.S., not really. Forget about it. Another gale forecast on Friday, but it's falling southeast and into the Ross Ice Shelf. Probably nothing from that. And that's pretty much it. It's just literally someone flipped a switch. Southern hemi was on. Now it's off. North Pacific woke up. And here we go. Fall is here. We're not really looking for wind swell anymore now that the northern Gulf is forecast to wake up. But we'll just take a quick look here. Get a general wind pattern. I'll try to look around the microphone here for a second. There we go. So Monday, so this is kind of the issue. There's supposed to be swell in Northern California, but there's this fetch, high pressure, 1028 millibars, nudging up along the coast, heat low inland, tightens up the isobars, creates wind, and you get a bunch of junk in the water for the swell that's hitting right now as we get into Monday. But come Tuesday, if there's any swell left, winds die off, trade's pretty light for Hawaii. As we get into Wednesday, trades build driven by this 1026 millibar high pressure system here. So maybe wind swell for the east shore of the Hawaiian Islands on Wednesday. Light winds along the California coast. Thursday, you kind of see this large low pressure, large fetch. Still a little bit of wind off of Cape Mendocino on Thursday and into almost Friday, but not really doing much. A light wind regime, and this is pretty typical for California this time of year. Indian summer, you don't have the northwest trade winds just blowing things, stirring the ocean up, pushing cold, salt air, encrusted air into the valleys and inland. Instead, you get light winds or no wind and pleasant temperatures and great conditions for surfing. And that's kind of looks like where we're headed. Saturday, trade wind swell still for Hawaii. Really no wind swell. I mean, little wind swell maybe Sunday, and that's it. The Gulf of Alaska just in control now, and it's quite a change indeed. Quick look for any potential for precipitation. Now, Whistler got some snow on the upper part of their mountains. Was it yesterday, I believe it was? I mean, not much. We're talking a couple of inches or something. It's probably all going to melt off. But we're looking down into the Pacific Northwest. We are seeing, with wave after wave of low pressure, precip, the blue colors here, working their way into British Columbia, but not even really down into the Pacific Northwest, and we're a week out. So, maybe light showers into Oregon at best, but nothing beyond that. And a quick look at Squaw Valley snow forecast dashboard. What are they called now? Olympic Valley. It's not Squaw Valley anymore. No snow forecast, but interesting. So all the summer up until maybe about a week ago. This chart here, the snow level has been nothing but red, meaning liquid precipitation above 14,000 feet. Now all of a sudden you're seeing the freezing level come down. Where's this? On the 22nd to maybe 12,500 feet just for a part of a day. But then after that, by September 26th, the snow level consistently comes down to about 12,500 feet. So a hint of fall perhaps starting to settle in even towards the coast. All right, let's go take a look long term. What's going on with the Madden Julian oscillation, that periodic weather oscillation that is effectively a low pressure and a high pressure oscillating pattern moving around the equator from west to east. Takes about 4 or 5 weeks to make it across the Pacific in the active phase. That's the low pressure phase. And that low pressure phase helps push energy up into the jet stream, which feeds the storm track. It also can create Kelvin waves, which if you have successive Kelvin waves, successive active phases of the MJO, can help set off El Nino, though we don't see that happening. And of course, we're going to also talk about the El Nino Southern Oscillation. Are we in La Nina? Are we moving towards El Nino? Where are we going? All right, so first off, MJO discussion. We're looking for signs of the active phase of the MJO. This is, and one of the components of the active phase of the MJO is wind. What it does is it will actually take trade winds and reverse them. The inactive phase amplifies trade winds. The active phase suppresses them. So this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they have wind sensors on them. Not like hourly wind, but 5-day average winds is what we can get, and that's good enough. It gives us a hint of what's going on. So this is the East Pacific here, West Pacific here. That's the equator. There's New Guinea right there. And we're just looking at the arrows. The colors are water temperatures in centigrade. But long arrows mean strong east winds. So those are trades over the East Pacific. Pretty strong east trades over the Central Pacific. And in the West Pacific, we call it the Kelvin wave generation area. When the active phase of the MJO is over here and it reverses trades. Now you see these arrows are out of the east and pretty strong. So pretty good indication probably that we're not in the active phase, but when the active phase is strong enough and over here, it can reverse these trade winds, and that does all sorts of good stuff in terms of feeding the storm track and potentially kicking off El Nino. But it's not the actual winds, it's the anomalies, the difference from normal for this time of year. So we look at these same regions, the East Pacific, you see winds are, just looking at the arrows, maybe a little bit stronger than normal out of the east here. In the Central Pacific, well, some of the sensors are down, so there's really no data here. But in the Kelvin wave generation area, trades stronger than normal out of the east. That's not a clear indicator at all of the active phase of the MJO. So let's look at the zonal wind anomalies. Okay, that's fancy words for are the winds blowing stronger out of the east or west than normal. The blues are east winds. That would be like inactive phase of the MJO, and the yellows, oranges are west anomalies. That would be the active phase of the MJO. But let's get oriented first. So 180, this is the whole planet on one chart. So the date line runs right up the middle. We know that the date line is in the sort of the central to west Pacific. The far west Pacific starts at 135 east, so right around along there. Kelvin wave generation area ends about 170 west, so right about there. So this is the area we're interested in, this box right here. And you can even look back. This is the whole month or a month ago. You can see just steady east anomalies building very strong on September 9th. And now forecast moderating some, but still strong in pockets, indicative of the inactive phase of the MJO. Certainly not the active phase. Whatever active phase there is, well, is somewhere over the maritime continent, just looking at this, and forecast building there. So that'd be like Bali or something like that. Certainly nowhere near the Pacific where we want it to be, at least for the next week. Let's go look out a little further. Another component of the MJO is clouds, right? If the active phase of the MJO is a low pressure system, well, low pressure generates clouds. The inverse is also true. The inactive phase of the MJO is like high pressure, and high pressure typically is clear skies, no clouds to be seen. All right, so this chart, outgoing long wave radiation, just shows you where are the clouds forecast and where are they not forecast. Oranges and reds mean a lot of sunlight reflectivity off the ocean surface, which means no clouds, which means high pressure, which means the inactive phase of the MJO. And the blues are the active phase. All right, so let's get oriented. Equator. 4 panels here. Each one 5 days in duration, starting with, actually it's yesterday's date, but the equator right there. Okay. South America, Chile, Peru, Galapagos, Central America, Mexico, Hawaii, New Guinea, Philippines, Australia. You get it. And Kelvin, the important part is the Kelvin wave generation area, this area in the West Pacific, 5 degrees north and south of the equator, from 170 west to about as far west as you can get, so 135 east, 5 degrees north and south. When the active phase is over here, that's when you get all the magic happening. It imparts energy to the jet stream. It can create Kelvin waves. It does all sorts of magic stuff. All right, so today's image says, well, kind of a mixed bag going on, neither active nor inactive. But according to this, the statistic model, the inactive phase is supposed to be setting up 5 days from now, building stronger 10 days from now, and holding still, if not building a little, 15 days from now. This model has been unwavering in this projection for the past 3 weeks or something like that. And conversely, the dynamic model has been saying just the opposite. A weak active phase, which is kind of modest in strength right now over the Indian Ocean, slowly moving to the maritime continent and then pushing into the West Pacific. And it hadn't changed for the past 3 weeks. So the two models, in fact, maybe we can just get a little bit set. There we go. There's the statistic model, 15-day outlook. The dynamic model, they're polar opposites of each other. The reality will probably be somewhere in between. Let's keep digging. A little more detail from those two models. Statistic model here, dynamic model here. This is the whole planet. And the MJO, this tracks the active phase of the MJO and its relative strength. So the active phase of the MJO and the inactive move from west to east, from the Indian Ocean to the maritime continent, over the West Pacific, the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is right here is where the active phase is today. So somewhere in between the maritime, somewhere between, let's say, probably around Bali, something like that, roughly speaking. The stronger this heavy dot is, or the further this heavy dot is away from the circle, the stronger the active phase is. So pretty weak. If it were way out here, then it'd be strong. So pretty weak. And here's the forecast tracks. All of them just like, they're all over the place. But basically, the active phase of the MJO, per this model, probably just noodling around right where it is and staying about the same strength. The dynamic model just sort of has it also noodling around, trying to make progress into the maritime continent, but only very weakly so. No clear sign of the active phase moving into the West Pacific, and much less being strong in the West Pacific. So a weak, if almost non-existent MJO pattern forecast for the next 2 weeks. Okay, so let's go look at the upper level model. This is from this is a portion of the statistic model, we believe. But anyway, this shows potential for precipitation. Greens are wet, which we loosely equate with the active phase of the MJO. Oranges and reds are dry air, which we loosely equate with the inactive phase. There's 8 panels here, so 5 days a panel goes out 40 days. South America there, Peru, there's the Galapagos, Ecuador, Central America, 1 pixel of Hawaii there. Oh, the equator right there. New Guinea there, Australia. Okay, you get it. Kelvin wave generation area right about here. So today, inactive phase, it looks like moving over or under the U.S. West Coast with sort of just a weak active pattern, if you want to call it that, pushing into the U.S. West Coast or actually into Central America in early October, but then followed by something that almost looks like another active phase. But the short of it is there's no real consolidated picture here, nothing strongly pushing one way or the other, and this goes the whole way out till when? The end of October. So a weak MJO pattern forecast through the fall, according to this. Then we go to the CFS model. This goes out a month from 18th of September to the 16th of October. All right. Kelvin wave generate, same deal, whole planet on chart. This shows the east-west component of the wind, so not sunlight reflectivity off the ocean surface, not precipitation, just are the trades, and this is really the part that matters the most, is are the trades stronger than normal or weaker than normal? And we want to see weaker than normal. The blues are stronger than normal trades, though. So let's get ourselves oriented. Date line right here. Far West Pacific, about 135 east, so right there. So this is the box that we're interested in. This is the Kelvin wave generation area. And all I see is blue, 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 and blue for the next month, meaning pretty much a continuation of where we are right now. Now, the blues, a bit weaker perhaps, but then they come back. So this dotted thing here, that's the inactive phase of the MJO. So, and you can, back here, you can see a previous active phase and previous inactive phase moving from west to east over time. So the waves go across the Pacific like that. You can see maybe we're in some sort of a weak inactive phase right now. And the models project a active phase developing in October. Now, earlier runs actually had it more like up in here and pushing further into the Pacific. So a little bit of ambiguity here about when. I mean, clearly some inactive phase is going to be pushing out, but whether an active phase comes in, a little bit undecided per this chart. Let's go look at one more. All right, so here's the 3-month CFS model. Past performance here, future forecast on top this time. Date line runs right up the middle. Kelvin wave generation area starts 135 east, so right about here. Draw a box in your mind's eye right about like that. What you see is here's these east anomalies that are in control. They're supposed to hold for another week or so. Then notice they're slowly supposed to slip east, and Kelvin wave generation area ends right there. And out of the Kelvin wave generation area by the end of October. And what do we get replacing that? Westerly anomalies. Not strong, but consistent, just homogeneous westerly anomalies, with these easterly anomalies slowly fading out and dissipating as we get into mid-December. If one is to believe that, that would be a pretty good sign. Let's overlay the MJO here. Oh, and one other thing. Okay, so these, we told you, because we talked with the main guy that built this site, this was the 0Z run, this was the 6Z run, the 12Z run, and the 18Z run, and this is all of them averaged together. Then we talked a little bit more, and he goes, you know what? He was wrong. He made a mistake. And the CFS model has 4 different ensemble members. I am not certain what the differences are in the ensemble members, but this whole model is just the 0Z run of the CFS model. It just updates once a day. And this box is the average, if you will, the mean of all these 4 different members. And in talking with Kyle McRitchie, the guy that built this site, he said the best thing to do is just use the average here. You're not, rather than picking at each individual one, you can do it. And we did it last week. You can go back and look if you want. In fact, here, we'll do it real quick. You can see there is some subtle differences in the way each member, there we go, presents its data. But it's the sum of all of them that's probably, or the average of all of them, that's probably the best indicator, he says. And he's got a PhD in meteorology and built this chart, so I'd say he probably knows what he's talking about. Anyway, so the solid contour is the active phase of the MJO. The dotted contour is the inactive phase. So if here's today, and this is the Kelvin wave generation area, we have the inactive phase in control right now. But starting about 5th of October, it's going to be out of the Kelvin wave generation area. And a weak active phase slowly sets up and really slowly plods across the Pacific, and it doesn't exit the Kelvin wave generation area until 16th of December. So from, let's say, the 27th of September, almost 2 months to make its way across the Pacific. And it doesn't do a whole lot in and of itself, but what it does is it supposedly drags westerly anomalies, filling the Pacific, which almost gets us kind of back to a normal, not a La Nina type pattern, at least looking at it like this. Inactive phase behind that, but even that just produces westerly anomalies. So then we overlay the low pass filter. This is a high or low pressure bias. Now, this suggests the dotted contour is a high pressure bias. So the date line's right there. We're already in it. Weak high pressure, just sort of this bias towards high pressure over the Kelvin wave generation area now. And then maybe starting to track off to the east as we get into December with a low pressure bias that's currently over the maritime continent today, trying to ease its way, the leading edge of it easing into the far west Pacific as we get into December. What this sort of suggests is, yeah, La Nina is going to be here, and maybe it's even almost peaking right now. That's me just making up stuff, and I'll show you why in a minute I say that. But that the deeper we get into fall, the weaker theoretically La Nina is going to become. And we're not going to move to an El Nino scenario, but we're going to transition into just a normal state. Now, even if with all these indicators, if all this comes true, which is hard to believe a model 3 months out, but assuming it all does, there's still a lot of momentum in the atmosphere, and the momentum is towards La Nina. So we don't expect that magically all of a sudden when we get to December 16th, boom, it's going to be just like a completely normal year. No, most of this year is going to be biased towards La Nina, but not nearly as strong as last winter, which means perhaps there's a chance we could eke out some better opportunities for precipitation into California and some better opportunities for large surf. Last year we had large surf, but it was all confined to literally like a 5-week window. And nothing happened before, and nothing really happened after that. This might open the door to a broader swath of larger surf over the entirety of the winter instead of just cram-packed into a tiny little window. With that, let's start looking more at the El Nino, La Nina sort of situation. See if we can tease out some bits about that. All right, so back to the TAO buoy array. Those buoys strung across the equator, used for monitoring El Nino. But we're not looking at surface winds now. We're looking down in the ocean. So this is the West Pacific here, East Pacific here. These little X's, well, these are the anchor lines on the buoys themselves, whole way across the Pacific, anchored in very deep water. The X's are the sensors on the anchor lines. You get the temperature data from all these sensors, and then you apply a model to fill in the gaps, and you get sort of a profile of where the warmer and where the cooler water is in the ocean. We're really only interested about the top 200 meters or top 150 meters. Pretty clear here, the 29 degree isotherm is gone. It was here. It's completely vanished. 28 degree isotherm holding steady about 175 west. I think that's where it was last week. The 24 degree isotherm has been holding steady about 125 west, so no big change. Warm water, mainly in the West Pacific, very thin, shallow area of warmer water. They call this the thermocline and the thermocline depth. Very thin warm water in the East Pacific. Now it's, again, the anomalies, differences from normal for this time of year. Now also notice in this chart, there's a big blank thing here. See these little X's? There's no X's there. It's because a bunch of the sensors on these buoys are down. So the model's literally just making stuff up. It has no guidance whatsoever on what to do. But there's good data over here, sensors here. So warm water was that maybe 1 degree above normal in the West Pacific. Maybe a little bit of warm water, very shallow in the East Pacific. But in between, well, there are some sensors right there, and they're saying 2 degrees below normal there. And these sensors here are hitting at 1 degree below normal temperatures. So it's probably safe to say there's a pretty cold batch of, it's almost like an anti-Kelvin wave, a cold water Kelvin wave pushing to the east. Now there's another model that uses the same sensor data above, but also uses some other data. I think it incorporates the ocean height. We'll get into that one, data. And anyway, this one, much more stark and dramatic depiction. Again, we're looking down 200 meters. Warm water, warm temperatures confined to the far West Pacific, not making it over the date line. And colder, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Like 6 degrees below normal. Now that seems completely far-fetched too. This is the area where the sensors are down, so who knows really what's going on here. Let's go look at one other piece of data. So you can't argue with this. This is data from the Jason 3 satellite image. It's ocean surface height. That is, you strip away the wave height, strip away the wind waves, strip away the tide. And it's the sphere of the ocean higher or lower than normal. The satellite beams down radar, I believe it is, and it's very accurate to like within 2.5 centimeters. Okay, it is showing this big negative pool, and it's only on the equator that, oh, let's get oriented, sorry. Chile, South America, Peru, Ecuador, there's the Galapagos, Central America, Mexico, there's the date line, there's the equator there, New Guinea there, Australia there. All right, and what this is depicting is these are above normal sea heights. Warm water, where are we there? Warm water expands, it pushes the water above it up, creates a bump on the ocean surface. That can be interpreted as, that bump can be interpreted as warmer than normal ocean temperatures at depth. The negative, cold water, contracts, it creates a divot on the ocean surface. And so one can infer there are colder than normal temperatures here. And the more negative the sea surface height is, the colder the temperatures are. So that what, -7 degrees on the previous model is probably being driven by this -15 centimeter reading here. So the inference being that there's a good sized pool of cooler than normal water at depth under the equator, which would not be surprising in a typical La Nina scenario. And then here is the same data, but it lays it out in a timeline. It goes back a year. So you can go back about a year ago. This is the West Pacific here. This is the East Pacific here. The blues are below normal temperatures. The reds above normal temperatures. So this is the development of La Nina peaking out in November with, I don't remember how negative it is, but pretty cold temperatures. You can see that held the whole way through winter into March. And then March is typically where you get this transition. You see a Kelvin wave. Active phase of the MJO pushed over the West Pacific, took warm water, pushed it east almost to Ecuador. 1 Kelvin wave, 2 Kelvin waves, 3 Kelvin waves. And then with that, the atmosphere goes, no, we're done. And there's no more warm water over here. And no more active phases of the MJO. And boom, right back. The trades start nuking. Cold water starts building up in the Pacific. Now the interesting part, so this is, it's really kind of peaking around 143 west, where was this? This was about 133 west, and not nearly as cold so far. So our hope is that this cool pool will be displaced to the west a little bit, and that it won't be as cold as last winter, but still we're, this peaked in the end of October. We've got another month to go till we get there. So we'll see how this plays out. Keep this in mind as we start getting into some of the models here in a minute, talking about where surface temperatures are going to be. All right, let's go look at the ocean surface, what's happening, right? We've talked subsurface, we've talked winds and MJOs and all this kind of stuff. But at the end of the day, it's this ocean surface. That is the boundary between the atmosphere and the ocean surface, and it's the integration of the two, the interplay between them, that drives our weather patterns, drives El Nino or La Nina. Right, so South Chile here, Peru, Ecuador, Central America, Baja, California. The equator right there in this image, or right there. These don't line up exactly, but you get the general idea. There's the Galapagos right there. All right, so what do we have? Well, in the Pacific, we have warmer than normal water right on the equator and north of there, out to a point south of California. We have colder than normal water south of the equator and building off of Peru and Chile. And yeah, we have warm water further south than that, but the reality is it's 5 degrees north and south of the equator. So like here, or in this image, it would be something like that. And by and large, you have cold water from the Galapagos the whole way out to the dateline on the equator. This warm water really doesn't count in terms of what's driving the jet stream. And it's really the water out here starting at 120 in the Nino 3.4 region. 120 west, 5 degrees north and south of the equator, out to 170 west. So you can draw a box right there. Just eyeball it and you go, well, I see a little bit of warming there, and there, but by and large, all this is colder than normal temperatures. That would suggest a La Nina pattern. Let's go look at what is the trend. Okay, for the past 7 days, these reds are warming temperatures. The blues are cooling temperatures, and it's only right on the equator that matters. None of this stuff all around. I mean, that matters to somebody, but in terms of driving the jet stream, it's really like in here. And what we see is kind of a mixed bag. Warming here, cooling here, but if you watch this day after day, week after week, none of this is like really lighting up and saying, oh, there's something we need to be concerned with. This is pretty much like, okay, business as usual. So then we just back off and look at the overall picture, and you can see on the equator, colder than normal temperatures. We really kind of were thinking we want to see the coldest of the cold out here, and we're hoping that some warming develops in here. You can see that little bit of warming there, but hard to discern any clear pattern other than to say things are colder than normal. Sea surface temperature trend in the Nino 1.2 region, that's the area just right there by the Galapagos and Ecuador, the far east Pacific on the equator. Well, this summer, temperatures were hovering right around even. And then as we got into August, they started falling. Now they're just toggling around. Today, 645 thousandths of a degree below normal, so a little more than half a degree below normal. Not surprising. Look at the charts. I'm actually kind of surprised it's that warm. And then in the official El Nino monitoring region, the Nino 3.4 region, the area south of California out to about the dateline today, temperatures 0.372. The scaling is different here, so don't get confused. The scaling here, temperatures were warmer than normal in June, and now we're falling back into the La Nina pattern, but still, you got to be at half a degree, and we're 372,000, so a third of a degree below normal. We're not even in La Nina territory right now, which is kind of a good thing. Okay, that says, yeah, we're colder than normal, but we're not officially La Nina, according to just the surface temperature data. And then finally, what's going on with the atmosphere above the ocean? Okay, we know the ocean is colder than normal. Typically, colder temperatures depress evaporation, and if you don't have evaporation, you can't get clouds, and if you can't get clouds, then what you end up with is building high pressure. Right, so this index, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. And this index, I think it's been around for over 100 years. Daily pressure readings at these two locations. Tahiti, roughly over the West Pacific in roughly the Kelvin wave generation area. Darwin, roughly in the Indian Ocean. When you integrate these two numbers, you get a value, 12.42 today. When this value is positive, like it is today, that's indicative of high pressure or the inactive phase of the MJO or whatever. This is just a daily reading, so we're going to look down over the whole list for the past month. Nary a negative reading to be seen. That suggests building pressure over Tahiti, higher pressure. So let's average this all together. 30-day average, 10.48. That's clearly a inactive phase of the MJO type pattern. And where is it going from? Well, we were down to 3. That was the lowest we were. And now we're up to 10. So at least a minimum inactive phase of the MJO. I mean, the MJO runs in like month-long, 5-week intervals. So we'll call this our MJO indicator, suggesting inactive phase of the MJO. And since we've had, easterly anomalies for a month now, no big surprise there. The 90-day average, positive also, 9.66. And what's the trend here? Just looking, well, we're building from 5.16 up to almost double that, 9.66. So this would probably suggest a return of a high-pressure pattern in the Pacific, a high-pressure bias, which is the hallmark of La Nina. Let's take that 30-day average, graph it out. Here we are today. What was it, about 10 or 10.5, something like that? Okay, but it's not the actual value. I mean, it is, but it's not. It's the trend. So let's go back January 2019. Lots of negative numbers. So these are the active phases of the MJO pushing the index lower. The rises are the inactive phase of the MJO. So clearly, active phase of the MJO dominant in 2019, pushing us towards a weak El Nino. And then as we got into 2020, boom, the inactive phases completely there, took over, pushed us into La Nina. We kind of got a little bit of a break. And now we're seeing the same thing, inactive phase, inactive phase, inactive phase. It looks like a return of La Nina. So go look at the CFS version 2 model forecast for the Nino 3.4 region. That's the official El Nino monitoring region in the Pacific. Sea surface temperature anomalies. Well, here was last winter. Temperatures down to minus 1.3 degrees, something like that. Then temperatures almost returned to normal as we got into June and July and even August. And now the model you can see it for yourself. It's projecting temperatures falling even worse than what we were last winter, down to 1.75 degrees, negative 1.75 degrees. Seems hard to believe, and you notice this model thought that this progression would start back in like August, and it hasn't. And it hasn't. And what happens is this keeps getting deeper and this keeps pushing off this way. Just doesn't seem particularly realistic. We're not saying it's going to happen. But this is also like the raw data. The PDF corrected is considered the more correct the more accurate version. Still, minus 1.45 degrees, beating last winter's minus 1.35 degrees. Even that seems a little bit suspect, but we'll see. The interesting part is there is just nuking east anomalies over the Kelvin wave generation area. And the models are like, what's it going to do? What's it going to do? They can't make up their mind, and it just sits there and it holds and it holds. And the more it digs in, the more this is going to become a possibility. And I think that's what this model is sensing, that the east anomalies aren't moving. Now remember, we have this active phase of the MJO, long-lasting, what is it, like a 2.5-month active phase forecast, building starting in a week or so. So if that happens and westerly anomalies build, it seems highly unlikely that we're going to end up down here in the mud like this is depicting. I don't want to say it isn't going to happen, because if I say it, then it will happen, and then we're in a world of hurt. But if the active phase develops as forecast, and even if it's weak and it just does anything to kill those easterly anomalies, then this isn't going to happen, and maybe we'll end up somewhere in the, maybe 3/4 of a degree below normal, something like that. But right now, nothing seems to be budging those easterly anomalies over in the Kelvin wave generation area at all. But the good news is, so all that's going on, and there's this high pressure bias over the dateline, but we still have the change of seasons, and that tends to trump some of this other stuff, the the weak MJO patterns and all that. So we have gale after gale after gale. Forecast for the northern Gulf, a little bit of swell, a little bit for Hawaii, a little bit more for the U.S. West Coast. Change of seasons happening on cue. Can't be happier, and we've just got over a good long run of southern hemiswell. No more of that is forecast, but for right now, looks like rideable northwest swell for mainly points north of Point Conception and for Hawaii, though we think the focus this year is really going to be on the northwestern Gulf of Alaska, which will favor like the Pacific Northwest down into North and Central California. Beyond that, well, we have this La Nina thing that's supposed to be rebuilding. The outcome is highly unclear at the moment. It could be pretty bad, or it could be almost nothing, and the models can't seem to figure it out, and the atmosphere is just doing what it's doing, and we're just going to have to go along for the ride and see. So long term, probably La Nina, but hopefully not too bad. And we're kind of hoping that as we get into December or so, even whatever La Nina we have will fade out. So the next couple weeks are kind of key. All right, so like we said before, if you enjoyed the video, give us a thumbs up. Comments, please submit them. We'll reply to them. We'll post the link at the top of every page of stormsurf.com so you can view it if you're not subscribed. Otherwise, please subscribe. Also, next week we will not be doing a video. We're going to go take some time to go do something else. But the week after that, for sure, we'll be back and regular as usual. All right, thanks for watching. We'll see you again 2 weeks from now. Go surf, have some fun, enjoy hopefully good conditions, and stay safe. Take care. Goodbye.